Welcome to Ask and Learn.
We are given sets from I star, where I is an alphabet, and we are asked to construct deterministic finite-state automata to recognize each of these sets. So, let I be an alphabet. Now, our first set from I star is the empty set. In other words, a set of no strings. Now, let S0 be the start state. We know this exists because every finite state automaton has a start state. Now, since the empty string should not be recognized by the machine, it follows that the start state should be a non-final state. Now, suppose the first input is some element A from the alphabet. Then we have that this string should not be accepted, and so we'll want to remain at S0, which is a non-final state. And it follows that the resulting deterministic finite state automata will not recognize any strings. And so you may want to draw the graph on your own. Now in part B, we're given the set consisting of the empty string. Once again, we know that this machine is going to have a start state S0. Now because lambda should be recognized in the machine, it follows that S0 should be a final state. That way lambda will be recognized. Now, suppose that the string contains at least one element. So let the first input of a string be A for some A in the alphabet. We want that the string should not be recognized by the machine. Therefore, we should move from S0 to a non-final state, S1. And after that, no matter what the next inputs are, we should remain at S1. And the resulting automaton will only recognize the empty string lambda. In part C, we are given the set consisting of a letter A. Now, of course, let S0 be a start state. We see that the machine should not accept the empty string, and therefore S0 should be a non-final state. However, suppose that the input is A. In particular, it's this A from the alphabet. then we're going to move from the non-final state S0 to a final state S1, since this string should be recognized. However, suppose that there is an input after this A. Of course, we could also break this into another case. So suppose the first input is a letter B from the alphabet, such that B is not equal to A. They're not the same letter. Then we should move from S0 to a non-final state, S2. Okay. And we see that once we've moved to non-final state S2, we'll want to remain at S2 for any further input. Likewise, suppose there is an input at state S1, well, it should be that this string is not going to be accepted then. So we should move from S1 to the non-final state S2, and as before, we'll remain at S2 for any further